Okay, this is ELID, the triphenyl phosphine compound, right? The reagent for the Wittig reaction. The book says take 201 milligrams, which is 0.201 grams of this. Here I have taken 0.221 grams, that is 221 milligrams of that compound, ELID. Put that in the Olin flask and then add benzaldehyde. Right. Okay, here is benzaldehyde. We want to add 50 microliter of benzaldehyde. That's a tiny amount. Here is a syringe. I'm going to use this to take the 50 microliter. This is a 1 ml syringe, which means 1/10 of 1 ml is 100 microliter. Right. And half of that is 50 microliter, which is this much. Right. Very little amount. 1/20th of this volume is the 50 microliter. So a few drops basically. That's it. And put the benzaldehyde into the Olin flask. And then place a stir bar and stir this. This is a solvent-free Wittig reaction. You don't need a solvent. We have a solid reactant and a liquid reactant. So just these two reactant. I'm going to stir it without a solvent. Okay, place it on a hot plate and spin. Okay, but this is vibrating. Probably the flask will walk away. I'm going to clamp it. This is a room temperature reaction, and I'm doing the first reaction, which is synthesis of ethyl transcinnamate. It's a room temperature reaction, right? So just clamp it and spin. Make sure the reactants are contacting each other. We don't have a solvent. You know the purpose of solvent in a reaction. It gives a good contact between the reactants by dissolving them and bringing the molecules close to each other. But here I have a solid and a liquid, two reactants. They're not contacting well, so it's our mechanical stirring that's what creating the contact between them. So try to stir that properly. I'm tilting the flask a little bit so that the tiny amount of liquid will go to this side and make a good collision or contact with the other reactant. Right. Okay, after 15 minutes of stirring, I'm going to add the solvent hexanes. Alright, so let's add about 3 ml, approximately 3 ml of hexanes. 1, 2, 3. And let it spin for a few more minutes. Meanwhile, we're going to prepare the filtration setup. Right. Okay, the filtration setup is basically a pipette with some cotton in it, a piece of cotton in it, right? So pretty much like this funnel. This funnel has a filter in it. We're going to make our own filter in this pipette. So take a piece of cotton, right, and put it here. and tuck it in using another pipe. Right. Okay, this is similar to this. Okay. We're going to clamp this pipe it. So clamp the pipette over this flask. This flask is what we use to collect the filtrate, the liquid coming out of this filter. Right. I'm going to pre-weigh this flask. Let's take the weight. Okay, zero down the scale. Place the flask on the scale and note down the weight. This is the weight of the empty flask, 31.030 grams. Let's place this flask here. Okay, here is our reaction mixture after a few minutes of stirring in solvent hexanes. Right. So I'm going to transfer the liquid onto this filter to get the filtrate. Right. So transfer the liquid. Rinse this reaction flask with a little bit of hexanes. Okay, we only need the liquid, we don't want the solid. The solid is triphenylphosphine. Triphenylphosphine. 3 phenyl rings bonded to the phosphorus, double bonded to oxygen. Right, phosphorus is double bonded to oxygen. That is the white solid. I think it's one of the post-lab question. Right, what is the white solid? It is the triphenylphosphine. Okay. Now we have this filtrate. If you want, you can put some pressure on the top. Use the bulb, pipette bulb, to apply some pressure on the top to squeeze out all the liquid from the cotton. Right. Okay, now we have our product dissolved in hexanes. We need to remove the hexane using evaporation. Right. You can simply put on the hot plate to evaporate, but to speed up the process, we're going to apply some vacuum and heat. Right. Okay, the evaporation process. Here's our compound dissolved in hexanes. I'm going to put it on the hot plate. Okay, place the hot plate here. Right, turn on the heat. You know the boiling point of hexane, so just heat to that boiling point. You don't need to measure with the thermometer. Apply some heat. Right, so we're going to also apply vacuum, like in vacuum filtration. This is actually the flask we use for vacuum filtration, but now we are using that for evaporation. Right, our compound is in here. Usually in a vacuum filtration, we keep our sample or solid on the funnel, and the waste water or waste solvent will go to the flask. But this time it's opposite. It is your compound that you want. Right, so be careful when you connect the vacuum. This is not a simple vacuum, it's an aspirator. We are running the water We are running the water in the sink, and that creates vacuum here. When you turn on the water, right, it creates a suction here. So you need to be very careful not to flush the water into the funnel, into the flask, right? So turn on the vacuum first and make sure it's working, and connect this later. If you do the opposite, if you connect this first and then turn on the water, it is possible that water will go to your flask and mess up your compound. Right. Now you can see that the hexane is evaporating. It's with the heat and the vacuum, it's evaporating faster. And there is nothing in it, nothing on the funnel. It's just an empty funnel. We let the air pass through, right? Air pass through this way, and the heat okay. After all of the hexanes are evaporated, I'm going to turn off the heat and break the vacuum first. Again, we have to do in this order. Remove the vacuum first and then turn off the water. If you do the other way, water will go into your flask. Right. Now let's check the weight of this flask. You know the weight of the empty flask. Now this flask has some product in it. Okay, so this is the weight of the flask with a compound, with a product. 31.090 grams. 31.090 grams. Right? Subtract the weight of the empty flask from this to get the weight of the product. Now, how do you do the calculation? We started with how much illid. It's not the amount the book says. We added a little more than that. I think 0.22 something, more than 200 milligrams, right? Convert that into moles. I convert that into moles, which it could be more. It should be more than 0.57 millimoles, the amount the book recommended, right? It could be 0.60 or more than 6.60 millimoles. So use your math to convert the actual amount of the reactant, illid, into millimoles. That is our limiting reactant. And convert this weight that you got into millimoles, right? Using the molecular weight of the product.